beryllium trichloride. So this molecule is octet deficient, octet sufficient with odd number of electrons. Which one is correct one? Is it octet deficient? Is it octet sufficient? Is it octet expanded octet?
Expanded.
So octet
Octet
deficient.
deficient.
Yes, sir,
Octet is
octet
sufficient, octet deficient.
So
deficient, sir.
deficient.
How many electrons deficient?
2.
3.
Three.
See, boron, in the valence shell of the boron, after bonding, how many electron pairs are present? After bonding. This is a
Three.
boron atom.
Two.
This boron atom having how many bond pair of electrons? No answer.
Three.
3 means 3 into 2, how many?
6.
6 electrons. So in the boron, how many electrons are present in the valence shell?
2 deficient.
6.
So yes, how many deficient? 2 deficient. This is octet deficient molecule. Octet deficient molecule. BeCl2. BeCl2. Is it BeCl2 octet deficient, expanded octet, or octet sufficient?
Sufficient.
Octet sufficient or octet deficient?
Sufficient.
Deficient.
Octet
Deficient.
Right,
deficient.
deficient.
How many?
Deficient.
How many electron deficient?
2.
Just
No, sir.
count. One bond means 2 electrons, two bond means 4 electrons. In the beryllium, how many electrons are present?
Oh.
So it is 4 electron deficient.
8 minus 4, how many?
4.
Four.
4 electron deficient. Though it is a stable or unstable?
Unstable.
Stable.
It is
Stable.
stable, it is not unstable. But Valence theory could not explain. Vesper theory also could not explain why BeCl2 is a stable molecule, and it will be explained by the theory called valence bond orbital theory. Next one we are going to discuss that only. So beryllium dichloride, though it is electron deficient, 4 electron deficient after making the bond. After making the bond, this is electron deficient molecule. Though it is electron deficient molecule, this is highly stable. Why it is stable? Not explained by the valence electron theory. Why it is stable? Not explained by the Vesper theory also, not explained. Which theory will explain this? So octet deficient molecule like BCl3 and so beryllium dichloride, which theory explain means valence VBT theory can explain. So that we'll discuss later after this class. Is it clear now?
Yes, sir.
Yes, sir.
So now central atom not having, central atom having means no lone pair, and how many bond pairs? 3 bonds pair over, no lone pair, 4 bond pairs. 4 bond pairs. What will be the shape? Central atom, no lone pair. A I am taking for example, and it is making how many bonds? How many bonds it is making? 4 bonds. A not having any lone pair. 4 bonds it is making. Is it octet sufficient or octet deficient?
Sufficient.
Sufficient. Excellent. How many? 2 into 4. 2 into 4. 8 electrons. So now central atom octet is sufficient, excellent. 4 bonds it is making. and no lone pair of electrons between these two adjacent bonds. The bond length, bond angle will be 109. The shape will be, what is the shape of this molecule? Tetrahedral or not?
Tetrahedral. Yes.
Tetrahedral. So tetrahedral means bond angle is 109 degrees without lone pair in the central atom. The bond pairs only 4. So 109 degrees. What is the geometry? Tetrahedral geometry. Without lone pair. How many bond pairs? 4 bond pairs.
4.
Tetrahedral shape. So, and now, again, one more. If the central atom of the molecule, has how many bonds? 1, 2, 3, 4, 5. Without lone pair of electrons. What will be the shape of the molecule? 1, 2, 3, 4, 5. No lone pair. 5 bond pairs. 5 bond pairs. 5 into 2, how many?
10.
10 electrons. Is it octet sufficient or expanded octet? Octet deficient molecule.
Sir, expanded.
This is an example for expanded
Octet.
octet. Is it stable or not stable?
Sir, not
Stable. Yes.
It is stable. It is stable, but it was not explained by valence electron theory, Vesper theory, not explained. So why the central atom has more than 8? Why it is stable, not explained, but explained by VPT theory. So then what will be the geometry of this molecule?
pentahedral.
How many corners? How many corners? 3 corners. Trigonal. Trigonal. 1, 2, 3. Bipyramid. One is below the plane, other one is above the plane. Below the plane, above the plane. Then complete the geometry. Clear everyone? What is the geometry this one?
Trigonal bipyramidal.
Trigonal bipyramid. Bipyramid shape. Then how many bond angles are possible in this? 2 bond angles
Sir,
are
2.
possible in this. One is 120 degrees, another one is 90 degrees are possible. So here, where the 120 degrees, here is the 120, means 120 degrees, and here will be the 90 degrees. 90 degrees. So this is trigonal bipyramid. Example, can you give example? Example is PCl5. What's the name of the compound?
Phosphorus.
Phosphorus chloride.
Phosphorus pentachloride. Phosphorus pentachloride. Phosphorus. How much valency electrons of phosphorus? 5. Valency of phosphorus how much?
5.
5.
5. So 5 electrons. 5 into 2. See here. Here is a chlorine. 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 And if you make the geometry, this is trivalent property here, and here is a pentavalent. Is there any lone pair on the phosphorus? No lone pair. No lone pairs. What kind of geometry this is?
Trigonal bipyramid.
Trigonal bipyramid shape, expanded octet molecule. Bond angles, how many are there?
2.
Two. One is 120, other one is so
90.
yes. So if you just take this PCl5 solid upon heating, you will get PCl3 and Cl2 molecule. What is the reason means? So first bond, because here two bond lengths are different, PCl3 means 1, 2, 3. These bonds are stronger and this bond and this bond are weaker. That's why first these bonds are broken. So that's why you'll be getting PCl3. So like this, and Cl2 you will be getting upon heating. So this will show that PCl3 has two kinds of bonds, longer, shorter. Next, according to Vesper theory, another example I will take. If the central atom not having lone pair, but having the bond pair of electrons. How many? How many bond pair of electrons? 6 bond pair of electrons. 6 bond pair of electrons. So if A is the central atom having how many bond pair of electrons?
6.
6 bond pair of electrons means it will make how many bonds?
6 bonds.
6 bonds it will make. So B with the B atom with the B with the B. So B atom. Then how many bonds are formed? So 6 bonds is expanded octet, electron octet deficient. Which category this is?
Expanded.
Expanded. How many
Expanded
electrons?
of
6
the
into
4x.
6 into 2.
So
How much?
12. 12.
12 electrons. Central atom has 12 electrons, more than octet. Is it stable?
Yes,
Yes,
sir.
sir.
It is stable, not explained by the valence orbital, valence electron theory and Vesper theory. And what will be the geometry of this molecule?
Octahedral.
Octahedral geometry. Octahedral geometry. This is octahedral geometry. So this is octahedral geometry. Polyhedral surfaces it has. So this is octahedral geometry of the molecule. Bond angle is 90 degrees. And imagine the bond angle decreases. Actually, the molecule will go unstable. Reason?
So force of attraction.
Yes, if the bond angle decreases, what happen means between the bonds repulsive force बढ़ेगा,
Yes, sir.
internal strain बढ़ेगा. So, and due to the increasing of internal strain, the molecule split, the molecule decompose. So that's why if you take sulfur hexafluoride, if you take PCl5 upon heating, easily they undergoes decomposition process. Easily they undergo decomposition. Easily they split up into the stable product PCl3 and Cl2. What is the example for this molecule? AB6 type. AB6 type, what is the example means? SF6. What is the name of this compound?
Sulfur fluoride.
Sulfur hexafluoride. Geometry is octahedral geometry. Without lone pair, bond pairs how many? 6 bond pairs. Now I told the central atom not having the lone pair but having the bond pairs in its valence shell. The geometry, these I told. Now I am going to take up the molecules in which the central atom has a lone pair along with the bond pair. how will be the geometry? Now we'll see. You should draw the structures in your book also. Are you drawing or not?
Yes, sir.
Yes, sir, drawing.
Now the shape geometry of the molecules. Geometry of the molecules. Central atom having lone pair plus bond pair. Lone pair and bond pair of electrons. So here A is the atom, central atom. Example, having one lone pair. One lone pair, two bond pairs. Example, I am taking one lone pair, two bond pair of electrons. A can make how many bonds? So two bonds it will make with B. Molecule type is AB2 type. AB2 type. So here is a B bond, AB bond, but this molecule having the lone pair. Central atom having the lone pairs and two bond pairs are there. So is it the linear or non-linear? How will be the shape?
Non-linear.
Non-linear. Why the non-linear?
So one
There is
lone
the
pair is
existence
there.
of lone pair.
There is a repulsion between lone pair versus bond pair. So lone pair versus bond pair. So here this lone pair causes a repulsion between this AB. What is the example? We'll take this type means example is SO2 molecule. What is the SO2 molecule? Sulfur dioxide molecule between sulfur and oxygen. How much will be the bond angle? It is, what is the shape of this molecule? Angular or bent shape?
Then
Now, is the sulfur is octet sufficient? Octet deficient?
so deficient.
Are you sure?
Sufficient.
Sufficient.
1, 2, 3, 4, 5,
Yes,
6,
sir,
Wait.
sufficient.
7, 8.
It's sufficient.
Sufficient.
Sulfur valency how many? 6. So 1, 2, 3, 4, 5, 6, 7, 8. Or with respect to means here more than 8 also there. Here 1, 2, 3, 4. 1, 2, 3, 4. Oxygen ka 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Oxygen octet 2, 8. Oxygen 2, 8. Okay. So, but the sulfur here, one of the bond is, if it, one is the coordination covalent bond if you make, so double bond we have to check. One lone pair SO2 molecule. Sahi hai. So here bond angle how much it could be? 104. Like water molecule. Like water molecule is the shape. Next one is if the central atom having two lone pairs. LP how many? 2. BP how many? BP how many means 2. Two lone pair. A having two lone pairs, two bond pairs. What will be the geometry of this molecule? So here the bond angle will be the bond angle will be, so here also AB, repulsion is more. See, earlier one bond angle is not 104, this is 104, actually this is 104, earlier one is more than this. So here this is 104, example is water molecule H2O, oxygen, like this, bond angle is 104. Bent shape, this is also bent shape we say, so and example H2O. If the central atom having one lone pair, bond pairs how many? 3. Bond pairs how many? 3. Central atom having A, lone pair 1, bond pairs how many? 3. The shape will be pyramidal shape. Example NH3, 1, 2, 3. Repulsion between this lone pair. So bond will be bent. Bond angle how much? 107. 107 will be the bond angle, pyramidal shape we say. Ammonia molecule. And if the central atom having the, so two lone pairs, bent shape over, the central atom having the one lone pair and 4 bond pairs. One lone pair, 4 bond pairs. A will make how many bonds? 1, 2, 3, 4, but one lone pair is there. If the central atom having the one lone pair, 4 bond pairs are there. So repulsion between bond pair is there. Repulsion between bond pair also there in this case. Then what will be the geometry of this molecule is that the trigonal bipyramidal shape. So here the trigonal bipyramidal shape the molecule will be getting, because the lone pair also will be considered to be one bond like this. This is trigonal, lone pair will be present here and bond pair is present here like this. This is a B, this is a B, this is a B here, and here is the lone pair of electrons, and here will be the bond pair of electrons. So example for this molecule is, what is that? Sulfur tetrafluoride. Sulfur will make how many? One fluorine, second fluorine, third fluorine, fourth one, and here will be the lone pair. So trigonal bipyramid shape with lone pair, one lone pair. It is similar to PCl5. Clear? So next example is 3 bond pairs and 2 lone pair. 2 lone pair of electrons, 3 bond pair of electrons with the central atom having. So what is the example? Here is the molecule having A having how many bonds? 3 bonds with the B. Lone pairs how many? 2 lone pairs. Then what will be the shape? We will get, so 2 lone pairs, same trigonal bipyramid, ClF3 example. So here this is the shape you will be getting, trigonal bipyramid. So you can write Cl will make 1 fluorine, second fluorine, third fluorine. Here is the lone pair, here will be the lone pair, trigonal bipyramid. So this is the trigonal bipyramid of the ClF3 example. So this is otherwise called T shape also. T shape also we call this one. If the lone pairs are present, so here the writing the lone pair one side. Here is the lone pair we should write. Here will be the fluorine we should write. because lone pair repulsion is more, and one bond pairs are one side, lone pairs are other side. So that the repulsive force between them will be minimized. See here how these lone pairs will be arranged and bond pairs will be arranged means, so the arrangement will be such that so repulsive force must be minimized between them in order to give the stability. So the arrangement of the lone pair, bond pair will be such that so repulsion force must be minimized. In that manner, so that bonds will be arranged, lone pair will be arranged about the central atom. Only the purpose of arrangement of the electrons, whether lone or bond pairs, is that to give the stability for the molecule. To give the stability for the molecule, that is the ultimate purpose of that arrangement of the electrons in the outermost shell of the central atom. So last two structures also there. One is 5 bond pairs and one lone pair. So 5 bond pairs and one lone pair. So will be arrangement will be. So if A atom will make how many bonds? 1, 2, 3, 4, 5, and other one will be the lone pair like this. Then the shape is octahedral. Same F, sulfur penta. Example is BRF5. BRF5. Here is the central atom is BRF5. Here is a lone pair, octahedral geometry. So last one is pair planar structure. 2 lone pair, 4 bond pairs. If the central atom having 2 lone pair of electrons, 4 bond pairs like this, lone pairs are like this, so the geometry will be square planar arrangement. Example for this, what is a molecule is xenon tetrafluoride. Xenon is a noble gas. Only it can react with the fluorine under adverse conditions. So xenon tetrafluoride is a square planar structure with 2 lone pairs and 2 lone pairs and 4 BP bond pair of electrons. The structure will be a square planar according to the Vesper theory. So these are the shapes of the molecules. Here just now I told the this S double bond. Yes, this one bond angle is how much? 119 degrees. 119 degrees, this one. Okay, so these are the shapes of the molecules containing bond pair and lone pair. So this is over, and next we are going to discuss, we'll discuss about valence bond orbital theory. In the next class we'll discuss. Okay, so these are the shapes of the molecules. You can practice in the notes these, draw the shapes of the molecules as per the Vesper theory. Is it fine, everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So practice and read the lesson. Anyone not submitted the notes, please submit so that today I will review the assignment. Thank you all. Thank you so much.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.